Okay, I changed some of the numbers a little bit just to make sure I'm not giving away any answers, but here's what you need to do for this question. They're asking us to calculate the mean, the sample standard deviation, and the population standard deviation for each of these three groups. So you can pull up Excel, Microsoft Excel, or Google Sheets. Google Sheets is something you can just search in your web browser, and it's free, and it works really quickly. So I like Google Sheets just because it's so easy to get to. So there's my first data set. If I want the mean, I'm going to find an empty cell and type equals average, open a parentheses, click and drag the numbers I want to find my average for, my mean, and then close the parentheses. So there's my mean. That's what I'd write here, 5.75. And the sample standard deviation, find an empty cell, type equals STDEV dot S. Now, there's two differences. You could choose .p or .s. The sample standard deviation is .s. And then same thing, open a parentheses, click and drag the numbers, close your parentheses, and there's your sample standard deviation. 2.6299, wait, it says 4 decimal places. So this one, the 5 causes it to round up. So this would be, this would turn into 10, so the 1 spills over, that spills over again, so this one rounds to 2.6300. And then the population standard deviation for the data set, type in equals stdev.p. So that's the only difference between the last one. We type .p at the end instead of .s, and that's the population standard deviation. Same thing, we'll do the appropriate rounding, 2.2776 for data set A. Okay, that's all just data set A. I filled out that column. And they want you to do the same thing for data set B. So you could do the same thing. There's a button that allows you to copy the data to your clipboard. You'll want to clear or find a new space if you're going to type it. And then do the same process. For the mean, it's equals average. Open a parentheses, click and drag, close the parentheses. So for my mean, for data set B, it's 6.6667 because I round to the 4th decimal place. Then standard deviation, STDV.S. Click and drag, close the parentheses. Oops, I think I got something wrong here. I accidentally clicked while I was writing that. So click and drag, close the parentheses. So there's your sample standard deviation. You get the idea, right? And then for population standard deviation, same thing. So you're just clicking and dragging. So what does it show? So this last part wants you to compare these two things. The sample standard deviation is larger than the population standard deviation. I'll leave that for you, but you're just comparing the two numbers in the same data sets. You should see the same result every time. One is always larger than the other. Samples can have similar means, but different standard deviations. That's absolutely true. You could have a data set that has a mean of 100 and a standard deviation of 10. You could have a data set that has a mean of 100 and a standard deviation of 1. That's totally possible. Okay, so I kind of gave away an answer there. The sample standard deviation is smaller than the population standard. Oh, so it's one or the other for these two. I won't give it away on that one. Samples can have different means, but smaller standard deviations. Okay, this last one says samples can have different means but smaller standard deviations. It's true that they can have different means, but that wording is confusing. One has to be bigger than the other. If you got two different numbers, one is smaller than the other, right? They both can't be smaller to each other. So I wouldn't select that one just because of the phrasing. I don't know, I'm not a big fan of that multiple choice option because it's not about statistics, it's about really paying attention to what they mean by smaller standard deviations. One is always smaller than the other. That means one is bigger than the other, so I wouldn't select that one.